Good morning, students. Today we are discussing about basic geotechnical engineering, module 2, lecture 8 of 5th semester, soil structure, clay mineralogy and compaction of soil. So in that we are discussing about the Proctor needle compaction equipment and suitability and problems. So R.R. Proctor introduced an equipment to check the field compaction soil in terms of percentage achieved OMC and MDD in line with laboratory compaction OMC MDD. This technique is applicable if both laboratory and field test is one and the same. R.R. Proctor developed a calibration chart to check the field compaction moisture content after each layer of compaction. So this is the Proctor needle that they are used. This is the needle shunt, this is the needle point, sliding ring and the stem for calibrated ring. So what we have to do is after each layer of compaction in the laboratory, this needle has to be taken, it has to be pressed. So initially when water content is less, it takes less pressure to penetrate. So for lower pressure for a higher pressure it takes to penetrate. So higher pressure it will give lower water content. You mark this red point. Second trial, so pressure required less because water increases. Second trial, third trial, fourth trial, last trial more water will be there. Pressure required less to penetrate it. You will get a curve. So you have to take this chart to the field. Once each layer compacted, you take this needle, press it on the field embankment. Some pressure you will get it, mark that pressure here, and that pressure will touches this red line. Draw a downward line. Wherever it touches the x-axis, that water content is your field moisture content. If that water content matches with your OMC, obviously that corresponding density will be MDD. Okay, so this is your Proctor needle method. Then compaction control in the field, we are using different type of rollers. Smooth wheel roller we are using, pneumatic roller, sheep foot roller. For the different types of soils we are using different types of roller. Similarly, grid type of roller we are using, vibratory roller, tampers for machinery, small work like footpath work we are using this type of rollers. So coming to the problem, following a result refers to a standard compaction test, determine the optimization of the maximum dry density, also determine the degree of saturation, percentage air voids, and at the maximum dry density take G is equal to 2.7. Water content is given, bulk density is given, calculate the dry density. Dry density is gamma bulk divided by 1 plus W. You will get the dry density. Once you get the dry density, plot water content on x-axis, dry density on y-axis, you will get a compaction curve. The peak of the compaction curve will give maximum dry density, it is 20 kN per meter cube. Corresponding water content is 15% OMC water. Next, once you know that one, calculate void ratio. E is equal to Wg by SR, gamma D is G into gamma W 1 plus E. E is equal to gamma D is known, G is known, E is 0.46. Once you get E, substitute in this equation, you will get SR. And once you know the gamma D value, G and W and G value, you can calculate in a percentage air voids. Next, problem number 2. A laboratory compaction test on a soil having G is 2.68 give a maximum dry density of 18.2 kN per meter cube but a water content of 17%. Determine the degree of saturation, the air content, percentage air voids at a maximum dry density. What would be the theoretical maximum dry density corresponding to 0 air void at a optimum moisture content that we have determined it. So answer is void ratio E is Wg by SR, gamma D is G into gamma 1 plus E, E is 0.42, SR is Wg by E 96%, air voids is substitute in that previous equation 1.15, the maximum theoretical dry density, air content is 1 minus SR, Na is 0, so gamma D is gamma max, that is 19.1 kN per meter cube. So next problem, that is you have to practice by considering the similar type of examples. There are the rest of the references, and my MCQ question, for a compaction of silt, dash field instrument is used, sheep foot roller, smooth wheel roller, vibrator roller, pneumatic roller. What is the weight of the smooth wheel roller is required for the gravel? A is 5 ton, B is 10 ton, C is 15 ton, D is 20 ton. Proctor needle is used for A is compaction of soil, B is field compaction control, C is laboratory compaction control, D is none of the above. For compaction of coarse sand, dash field instrument is used, sheep foot roller, smooth wheel roller, vibrator roller, pneumatic type of roller. So for compaction of any soil in the field, instrument used is sheep foot roller, smooth wheel roller, vibrator roller, pneumatic roller. Then pneumatic type of roller, tire pressure can be adjusted as per requirement, true or false. The infrared method is a maximum field in the flow method, true or false. A calcium carbide method, you can the accuracy of method is 5, 10, 15, none of the above, true, which one is correct. Calcium carbide method is accurate method, determine emission method, true or false. In a pneumatic tire roller, tire pressure can be adjusted as per our requirement, true or false. Okay, so thank you for attending the class. So next class, if you have any doubt, you can feel free to ask.